Okay, so graphing and finding a solution is great, but the problem is if it's a decimal or a fraction, you can't really see that on a graph. And in Algebra 1, we have to be, in algebra, in math, we have to be able to be absolutely sure of the solution. And so now we're going to learn some algebraic ways to solve a system of equations. We still remember, we're just trying to find the point at which the two cross, okay? So I'm going to write it again, reminder. So write this down again. If you're not taking notes, it's a really good idea to take some notes and make sure you understand this. A solution to a system of equations is the point I'm going to put in parentheses the ordered pair. I don't know what this is about. Oops. I was so busy fixing that one. The ordered pair where the two lines cross. Don't lose sight of that. We're doing a lot of algebra, but we're still trying to figure out where the two lines cross. So that's the key to what we're doing this whole chapter, really, is where do these two lines cross? Okay. So let's look at an example. I have y equals 2x plus 1. And then I have 3x plus y equals negative 9. Okay? It's a good idea to use substitution if one equation is already solved for x or for y, or it's easy to solve for x or y. Okay, so in this case, we already have it solved for y. So again, we're trying to figure out where these two cross. So the one way we can do this is substitution. So I'm going to take the blue equation, 3x plus y equals negative 9. And because the green equation is solved for y, I'm going to take the blue equation and I'm going to take out the y and put in a mathematical blank. Now remember, a mathematical blank is parentheses. So instead of the y, I put parentheses. Now what am I going to put in those parentheses? Well, if this is one problem and this is a system of equations, y equals 2x plus 1 can be substituted in. I'm going to take this group here and I'm going to take it over and I'm going to put it in the parentheses because we know that's what y equals. It's the same y for both. So it doesn't, we can put in 2x plus 1 where y originally was. We're substituting, we're taking out the y, we're erasing and replacing the y with 2x plus 1 because in this problem you've been told that y equals 2x plus 1. Now that we've done that, let me do something here so that this isn't away. I'm going to draw it this way. There we go. Now that we've replaced that, we have one variable. We have an x. So we can just simplify and solve this equation for x. So we have, I don't know why I just did that, 3x plus, now is there anything on the outside of the parentheses to distribute? That's the whole point of putting parentheses, to make sure if there is something to distribute, we remember to. Well, there isn't, so we can just write 2x plus 1 equals negative 9. And now we're going to solve. We're not ready to switch sides of the equation, so we're not changing signs. 3x plus 2x, they can go together. We're not changing signs of the equation. So if we're not changing sides, we don't change signs. So this will be 5x plus 1. Now we're getting ready to move it from one side to the other. Remember, that's the only time we change signs is when we move from one side to the other. So I'm going to subtract 1 from both sides. And I get 5x equals negative 10. Divide both sides by 5, and x equals negative 2. This is only half of the solution. Remember, we need to know what's the y. We know negative 2 is where it's going to cross, but we need a point. So we're not done. So we want to go back and we want to plug negative 2 into one of the equations to solve for y. It doesn't really matter which one. The reason I'm going to use the green equation, though, y is already solved for. So I'm going to write y equals 2x plus 1 And now we know what x equals. Well, what does x equal? X equals negative 2. So I'm going to write 2 mathematical blank plus 1. And in that blank, I'm going to put my negative 2 that we just figured out. So can we figure out what y equals? Yes, because negative 2 times negative 2 is negative 4, plus a 1 is negative 3. Now we have our full solution, because now we know if we were to graph these two lines, they would cross at negative 2, negative 3. Negative 2, negative 3 is where these two equations are the same. We can use negative 2 and negative 3 in either equation, and we will get the solution. Okay? Let's do one more like that. And then you're going to this really just takes some practice of plugging in and solving. Okay? So let's start with y equals 4x plus minus 6. As soon as I see that it's already solved for y, I'm thinking I'm going to use substitution. Okay? Ooh, I want to change this up. Hold on. And so this is going to be y equals, because there's a couple in here like this. Is there? Let's see. I want to change to a different problem. Sorry, just hold on. Let's do this. Erase that. Sorry if you were using pen. We're going to do this one. Y equals 4x minus 1 and y equals 2x minus 5. We're going to substitute one for the other, okay? People get confused by this because they're like, well, they're both solved for y. If they're both solved for y, in this problem, we know that y equals y, right? We know that's true. Well, if y equals y, then we could go and put 4x minus 1 on one side, and then on the other side, we could put 2x minus 5. Because they're the two y's. If y equals 4x minus 1, y equals 2x minus 5, so we can put them equal to each other. Now, is this a solvable equation? It is. So I'm going to subtract 2x from both sides. Why? Because I want to gather my x's up on one side of the equation. Since I'm moving from one side of the equation to the other, I'm changing signs. So this is 2x minus 1 equals negative 5. I'm going to add 1 to both sides. So 2x equals negative 4. Divide by 2. Divide by 2. I almost put it negative. It wasn't negative. And x equals negative 2. Now here's the question. If you gave me x equals negative 2 as a solution, would it be correct? Well, it'll only be partially correct because I don't know what the y value is at negative 2 that we need to cross at. So we have to plug it back in. Again, it doesn't matter which one we plug it back into. I'm going to plug it back into the lowest one because it's right there. Instead of the x, I'm going to put a mathematical blank. In that mathematical blank is going to go that negative 2 because that's what we just figured out x equals. And then we're going to finish solving this. Y equals negative 4 minus 5, so y equals negative 9. Now, oh, I said negative 9 and I wrote that. Now we know that if we were to graph these two lines, they would cross at negative 2, negative 9. Now I'm looking at the homework because I want to kind of give you a hint here. And on the homework, all the answers are whole numbers. They're all integers. There's no decimals and there's no fractions in the homework. There could be that when we solve these, but for right now, I want you practicing the skill of substitution, so we didn't put any fractions or decimals as answers. So if you get a fraction or decimal, you did something wrong, and you need to go back and fix it.